Welcome everyone to geometry once again. We're going to continue taking a look at section 4 today, which is quadrilaterals. But we're going to look at the definitions now. So all of our definitions we want to write in a similar format. So we're going to have a blank is a blank in which something, okay? So that's what all of our definitions are going to look like. A parallelogram is a what? Well, a parallelogram is a quadrilateral. In which both pairs of opposite sides are parallel. Excellent. I'm going to use this notation for parallel to help us out a little bit. Give a nice little bit of shorthand. All right. A rhombus is a quadrilateral in which all four sides are congruent. Now I'm going to shorthand congruent as well. That is the symbol we use to say that two things are congruent to one another. So this means congruent. So a rhombus is a quadrilateral in which all four sides are congruent. All right. A trapezoid is also a quadrilateral, right? All of them are quadrilaterals. Will this really change any? Well, it will for one of these. So a trapezoid is a quadrilateral in which exactly one pair of opposite sides is parallel. And it's very important here that we notice the word exactly, right? We need to pay special attention to exactly. There's exactly one pair of opposite sides, which is parallel. This tells us that that parallelograms are not trapezoids. Okay, so parallelograms are not trapezoids because parallelograms have both pairs of opposite sides. Both pairs of opposite sides are parallel. And in a trapezoid, exactly one pair of opposite sides is parallel. All right, an isosceles trapezoid is a trapezoid in which, let's see here, the non-parallel sides are congruent. Excellent. Use of notation, both notations in that definition. A rectangle is a quadrilateral in which all four interior angles are right angles. Excellent. And then a square is a quadrilateral. This one is probably the longest definition for us. A square is a quadrilateral in which all four sides are congruent All right, so quadrilateral in which all four sides are congruent and all four interior angles are right angles. Excellent. So we can observe that if all four interior angles are right angles, then it has to be a rectangle. But if all four sides are congruent, that tells us that it's a rhombus. So we can call this, right, a square is a rectangular rhombus. Cool, right? So it's just two things. So a square is nothing new. It's just satisfies two other definitions. Or that's one way you can say it. A square is a rectangular rhombus. Or you can say it is a rhombical rectangle, which is just really fun to say. A rhombical rectangle. Haha, nah, fun. All right. So our last definition is a kite, and a kite is also a quadrilateral in which two separate pairs of adjacent sides are congruent. You'll notice that these definitions line up with some of the properties that were in that first activity. So feel free to go back to that activity and check some of those properties alongside these definitions to get an idea of any properties that you may have missed, or just find a better understanding of these definitions. So that is all that we want to do for now. So thank you again for joining me, and I will see you guys again shortly to continue talking about quadrilaterals.